All right, guys, in your last notes, we talked about the different types of research, and now we're going to look at experimentation. And experimentation, so just a brief review, here are the different types of research that we looked at. So we looked at descriptive, which were they were just observing behaviors with case studies, surveys, naturalistic observation, and then we talked about correlations and correlations coefficient. So now we're going to go down here and look at our experimental research method and talk a little bit about variables that you may remember from your science classes, but we're going to define them for our psych experiments. All right, so experimentation, its basic purpose to explore cause and effect. All right, and that's our next slide here. So experiment is really the only research method that isolates cause and effect. Okay, so remember last time we talked about correlations, where we looked at some different types of research can give us correlation between two variables, but then we made that big point of that correlation does not equal cause. Okay, so we talked about just because you have low self-esteem does not necessarily mean you're depressed. They might be correlated, you might find them together, but you're not going to necessarily identify cause. Experiment does that. Okay, so experiment is the only type of research that's going to say this causes this. Okay, so this is done much more in a lab procedure and very much is going to kind of build off of your scientific method from your science courses. So for these notes, you should have a handout from class, but basically what we're going to do is we're going to go through the terms that you need to know for the scientific or for the psychologic research method, and then on the other side you're going to actually be talking about this experiment. So I'm going to use this experiment as our example throughout the notes. So let me skip to the next slide. So I'm going to talk about the variables, and then you are going to write down the examples that go back to the experiment that we're talking about. So our fake experiment that we'll talk about for the next 10 minutes. So here's our claim. Here's what we want to test. That caffeine makes Antelope High School teachers more alert and happy. Okay, that is your claim. That's something you want to go out and test. So your hypothesis, remember we talked about it's an if-then situation or a sentence. It's a testable prediction. I can go out and test this with people. If teachers drink coffee, then they will be happy and alert. That is my hypothesis. If they drink coffee, they'll be happy and alert. So the first thing we have to do is define our operational definitions. Remember we talked about those before. How am I going to define my variables? How will I measure happiness? How will I measure alertness? Okay, those are old notes, so we won't go over those too much right now, but think about that. How would I measure how happy or alert teachers are? Okay, so the first thing we're going to do, our experiment, IVs and DVs, independent variables and dependent variables. So your independent, just think about those words for a second. So if something's independent of something else, that means that it's by itself. It's not affected by anything else. Versus if you are dependent, means that you are affected by other things. Okay, now let's put this into an experiment. So my independent variable is the factor that I'm going to change. Okay, so I change. This is the thing that is changing. So in this case, in our experiment, we would be changing whether or not the teachers got coffee. Okay, so that is the thing that is changing. And that's the thing what we're going to study. So my dependent variable is dependent on my independent. Say that one more time. My dependent variable is dependent on my independent. So my dependable variable is the one that I am measuring. All right, so in this case, we talked about we are going to be measuring whether or not a teacher was happy and alert. And that will change because of the amount of coffee they drink. All right, so dependent is dependent on the independent variable that we are changing. Rewind that, play it again. We'll talk about it in class. But for this situation, my independent variable is going to be whether or not the teachers have coffee. Okay, so let's say one group is going to get, we have three groups. One group's going to get coffee, one group's going to get decaf coffee, and one group's going to get some water that is brown that looks like coffee. Okay, so that's the thing that I'm changing, and then we're going to be measuring whether that affects how alert and happy teachers are. So designing our experiment, we talked a little bit in case studies and surveys of how we randomly sample, but now we're going to apply it to the situation. So just some straight definitions. My random sample means if I took the sample population here of Antelope teachers, every person on our staff would have the equal chance of being selected. Okay, so if I only want to take maybe I only want to do this with a couple or with a group of people. If I put everyone's name into a hat and then I randomly chose them, that would be a random sample. So everyone has an equal chance of being pulled out of the hat. Okay? Now that's different from a stratified sample. Okay? So if I wanted my population or the group that I'm testing to look like the staff, the population would be divided into subcategories. So what that means for our experiment that you're writing down to the side. So if we have 60% females staff and 40% males total, and I'm trying to get a stratified sample, I need to make sure that 60% of my people are female and 40% are male. Maybe I want veteran teachers, so older teachers versus younger teachers. So the population would be divided into subcategories, but then there'd still be people from each subcategory to represent. Okay? Now this is different from random assignment. Random assignment is when now I have my sample put together. Every subject should have an equal chance of being placed in either my experimental group or my control. Okay, so now that I have my sample, so I've picked the people from the hat, I have my random 60 teachers I'm going to look like. Now I'm going to randomly assign those 60 teachers into different groups. One group's going to have coffee, one group's going to have decaf coffee, one is going to have coffee that looks like water. Okay, so they're randomly assigned into groups. So the big key here, because we talked about random, stratified, is that randomization helps false results. Okay, so I'm trying to make it so that I'm just testing the independent variable, right, the coffee, and there's nothing else that's interfering. Okay, now in the last slide I talked about experimental versus control. Okay, so let's go back to our teachers. We've got 60 of them. The experimental group, okay, so I'm going to take them and break them into 3 groups, so 20, 20, 20. The experimental group is the ones that are exposed to the treatment, in this case, the coffee. Okay, so they have the one version of the independent variable, which is going to be the coffee or the decaf or the no coffee. Okay, now that's my experimental. Those are the people that I'm changing, okay, or changing the variables with. The control condition is the condition of experiment that will contrast the treatment. So I have to have people that have no coffee, right, because I need to compare them to something. So my controlled group is that group of 20 teachers that is not going to get any coffee whatsoever, or even the fake coffee, okay, because I want to be able to compare my group of teachers to each other, right? Is that this group of people that have coffee and then people that are not drinking coffee at all. Okay, so placebo. We've talked about placebo already, but I'm going to define it here for you. Okay, so placebo is it's a substance or a condition that is administered or given instead of the actual variable. And I underlined the key thing here, is it to see if it triggers the effects believed to characterize the active agent. That's super wordy. But what that means is it's a fake treatment. Okay, so if I think I am getting coffee, I'm going to delete this real quick. If I think I'm getting coffee, that might have the effect of actually drinking coffee. That's why it's called the placebo effect. All right, they do this all the time with drug studies. All right, so people think they are getting a certain type of drug. Let's say, another example, like when I'm trying out a new antidepressant, I want to make sure that the antidepressant actually treats depression. So what happens is they give half the people a placebo, meaning that the people think they are getting an antidepressant, but they're really not. They're just getting a sugar pill. Because sometimes just thinking that you are taking something actually has the same effect. All right, that's why it's called the placebo effect. People that think they're taking an aspirin tend to claim that they feel less pain. Okay, so you can actually like trick your mind into thinking that it's having an effect. All right, it's something that's been studied intensively in psychology. So my placebo, so let's reread through that definition. An inert substance or condition, right? So something I'm giving to be given, administered, instead of the presumed active agent. So instead of the real thing, such as a drug, to see if it triggers the effects believed to characterize the active agent. So see if that triggers in your head the effects that you think it's going to have. We'll talk about this more. It's basically a fake treatment. People think it's real. So for our experiment, which you're writing down there, what is the placebo effect? It's going to be those people that are getting the water that looks brown, They think they are getting coffee, all right? So are they going to be happy and alert because they think they're getting coffee, or is it because they're actually getting coffee? So two different things, single blind or double blind procedure. So a single blind procedure experiment would be where the participants don't know what type of treatment they're going to get. So I'm in control of this thing of the teachers, and I know which 20 are getting coffee, which 20 are getting decaf, and which 20 are getting water. So that would be a single blind. They don't know, but I do, okay? A double blind is where they don't know and I don't know who's getting it. Okay, the purpose behind the double blind is sometimes that the researcher in charge, when they know who has the different types of treatment, sometimes they treat people differently. Okay, so if I know Miss Cantrell is getting coffee and she's and I know she's getting real coffee, and I might interact with her during the day, and I might say, "Bet you're feeling really good." You know, and that's actually giving a little bit of bias to her. Maybe she's thinking, oh, wow, I must be getting coffee, even though she doesn't know. So if we both don't know, it makes it a more valid experiment, all right? So which one do you think is better and why? And is there any situations when you think it can't be that way, that there's a double blind situation? All right, confounding variables, all right? Confounding variables. These are bad. All right, just when you think confounding situation, bad. It's any other thing that could affect the outcome of the experiment other than the independent variable, okay? So the independent variable in our situation was coffee. Anything else that could mess with our experiment is called a confounding variable, all right? I'm not meaning to change it. It just happens to be confounding my experiments. You don't want these in your experiment. You really try and control as many things as possible. But again, when we're dealing with people, there are things outside of our control. We can only control so many things with people. For instance, an example for this experiment, how much sleep teachers are getting. So if I have 20 teachers drinking coffee, but some of them are getting 2 hours of sleep and some are getting 10, it's going to affect how happy they are, regardless of whether or not they're having coffee or not. Okay? Those are things that are outside of my control, but that could possibly change the outcome of my experiment. All right? So that's a confounding variable. I'm going to have you guys think of some more confounding variables and go through this example again in class. And then for the rest of the experiments that we'll be looking at throughout the year, we're going to do this type of situation where you write down the IV, DV, confounding variables, double blind, single blind, and then apply it to the experiment.